Thank you everyone. How are you? My channel name is Vidyut Flow. You may subscribe it. Today we start a new lesson which is known as Dual Nature of Matter and Radiation. It is a class 12 standard JEE at a preliminary level. বাংলায় বলে পদার্থের দ্বৈত ভূমিকা অথবা দ্বৈত আচরণ এবং বিকিরণ। This lesson is going to be solved with a lucid manner. As far as practicable, it will be shown in the board, and this lesson will be solved in one shot only. The de Broglie wavelength of an alpha particle accelerated through a potential difference V is given by 4 answers here. So let us answer the problem. We know lambda equals to h upon mv, where m alpha v, m alpha means the mass of the alpha particle, which is known as doubly ionized helium atom, is called alpha particle. বাংলায় বলে দ্বি আয়নিত হিলিয়াম পরমাণুকে আলফা কণা বলে। এখানে দেখতে পাচ্ছি আমরা this is v, velocity, half m alpha v square equals to k, kinetic energy of the alpha particle, from which we get v alpha equals to this. So h upon m alpha upon twice k equals to h upon root over twice m alpha k equals to h upon root over twice into 4 into mp into q alpha v, because k here is q alpha v. V is the potential difference and q alpha is the charge of the alpha particle, which is 2 times the charge of proton. So we can write here as h upon 2 into 4 into mp into 2 into e plus v equals to h 6.625 into 10 to the power minus 34. This divided by 4 times root over 1.67 into 10 to the power minus 27 into 1.6 into 10 to the power minus 19 v atometer. h এর মানটা বসালাম 6.625 into 10 to the power minus 34. নিচে mp, mass of the proton 1.67 into 10 to the power minus 27 kg, and electron charge of proton equals to 1.6 into 10 to the power minus 19 coulomb. This data should be quoted in memory for getting chance at IIT general entrance level. So we can write this equal to 6.625 into 10 to the power minus 34 into 10 square angstrom. This divided by 4 into 1.67 into 1.6 v into 10 to the power 23, because this is 10 to the power minus 46 root and 10 to the minus 3 equal to 10 to the minus 23. When it goes up this 10 to the 23, This is angstrom unit because 1 meter equals to 10 square centimeter equals to 10 square into 1 10 to the power 8 angstrom unit. So 10 to the power 10 angstrom unit. So here 10 to the power 10, here will be 10 to the power 10. Minus 1 this divided by 4. রুটের মধ্যে থাকছে 716 112 2 হাতে রইল 11 696 11তে 96 107 7 10 26. So here is the decimal point here equals to 6.6625. This divided by 4 into 2.672. 1.63 by calculator. Scientific calculator, this is used as 6346 25339 root V angstrom unit equals to 85 equals to 0.01 upon root V angstrom. So this is answer. So answer D. The maximum kinetic energy of the photoelectrons gets doubled when the wavelength of the radiation incident on a metal surface decreases from lambda 1 to lambda 2. The work function of the metal is this. We know from Einstein's photoelectric equation as H mu equals to E plus work function this. Now according to problem, lambda 1 is decreased to lambda 2. So this will be increased. And this time this is twice E plus omega 0. Sorry, W0. This is the work function. So from these two we can get W0. subtracting 1, subtracting 2 by 2 minus 1. 2 minus 1, we get AC by lambda 2 minus this equals to this. Cutting out, this is W0 minus 2W0. So answer D. For incident radiation of frequency is nu1. This problem is based on Einstein's photoelectric equation. The most respected scientist Einstein's photoelectric equation. The ratio of maximum kinetic energy of emitted photon electrons is this, the threshold frequency. So answer, we know H nu equals to E max plus W0, where E max is the energy, maximum energy of kinetic energy, and W0 is the work function. According to problem, H nu1 equals to this, which is equals to, we can write as H nu0, where nu0 is the threshold frequency which is to be calculated. What is threshold frequency? The frequency at which the electrons coming out from the metal surface, when light emitted, when light reflects, when light bombards a metal surface. And H nu equals to E max dash plus H nu 0. So E max upon E dash max equals to H nu 0, H nu 1 minus H nu 0, this divided by H nu 2 minus H nu 0 equals to 1 by n, implies H cutting out nu 1 minus nu 0, this divided by nu 2 minus nu 0 equals to 1 by n, from which we get n nu 1 minus n nu 0 equals to n nu 2 nu 2 minus nu 0 implies n nu 1 minus nu 2 equals to n minus 1 nu 0, implies nu 0 equals to n nu 1 minus nu 2, this divided by n minus 1. So answer হচ্ছে C. The energy and de Broglie wavelength of an electron are E and lambda respectively. Here E is the kinetic energy. Here E is the actual kinetic energy. গতি শক্তির কথা বলছি। Then the correct log E log lambda graph is given by 4 options. We know lambda equals to H upon root over twice M E. It comes from lambda equals to h by mv, and also half mv square equals to E. That E is the kinetic energy, not the total energy. From here we get this, put this here, we get equals to h upon twice m this. Now log lambda, taking logarithm on both sides, because here is the log lambda log e case, we get log of h by twice root m plus log of 1 by root e equals to log of h by twice m minus half log e. This is constant because h is constant, m is also constant. What is the m? M is the mass of the electron. So we can write this as, if it is compared to the equation y equals to mx plus c, you get this is mx minus c. We get this type of equation. Because when x put x0, we get y equals to the energy and de Broglie wavelength of an electron are E and lambda respectively. Then the correct log E, log lambda graph given by 4 answers, we have to find the correct one. We know lambda equals to h by mv, and we also know a half mv square equals to E. Here E is the kinetic energy, not the total energy of electron, but kinetic energy, from which we get V equals to root over twice E by m. Put here, we get equals to h upon root over twice me. Now taking logarithm on both sides, we get, why logarithm taking? Because the graph given by log lambda log e. So we get log of h by twice m plus minus half log of e, because e to the power minus half is the case here. So if it is compared to y equal to mx plus c, then we get m as minus half. What does it mean? It means if the angle making theta with the positive direction of x-axis, that is x অক্ষের ধনাত্মক দিকের সাথে যদি থিটা কোণ করে, তাহলে tan theta equals to here minus negative equals to negative. So this is the answer, which becomes this the, so theta is the obtuse angle here, obtuse angle for this case. When theta is negative, then tan theta is negative. When theta is obtuse angle, then tan theta is negative. This is for an example, is the obtuse angle, বাংলা বলে স্থূলকোণ. So tan theta is root negative, tan theta is negative. So the answer will be this. All the cases here is the theta is the acute angle, but here theta is the negative obtuse angle. So answer C. Radiation of wavelength lambda when incident on a photocell produces photoelectrons with maximum velocity v. For radiation of wavelength 3 lambda by 4, the velocity of the fastest electron will be this. We know photoelectric equation. We know Einstein's photoelectric equation as h nu equals to half mv square plus w0, where this is the Emax. So hc by lambda equals to half mv square plus h c by lambda 0, where w0 equals to h nu 0 equals to h c by lambda 0. So hc by lambda minus hc by lambda 0 equals to half mv square. So v square half mv square equals to hc 1 by lambda minus 1 by lambda 0. So v square equals to v equals to 1 by lambda minus 1 by lambda 0. When the wavelength implemented here as 3 lambda by 4, then we can write v dash equals to twice hc over m, because this one is constant, 1 by 3 lambda 4 by 3 lambda minus 1 by lambda 0. So this one is 1, this one is 2. So 2 by 1 we get v dash by v, 2 by 1 we get v dash by v equals to this divided by 1 by lambda minus 1 by lambda 0 equals to 3 lambda 4 lambda 0 minus 3 lambda, this divided by lambda 0 minus lambda. That is by V equals to that is by V equals to root over 4 by 3 4 lambda 0 minus 3 lambda, this divided by 4 lambda 0 minus 4 lambda. Now we can say that 4 lambda 0 minus 3 lambda upon 4 lambda 0 minus 4 lambda, because 4 lambda 0 minus 3 lambda, 6 minus 1 by 6 minus 2 equals, we can write this one will be 5 by 4 greater than 1. Suppose 4 lambda 0 to 6 by an example. So 6 minus 1, this divided 6 minus 2. You can get, so this one is greater than 1. So you can write V dash upon V greater than root over 4 by 3. So V dash greater than D. So answer D. The wavelength of incident light is lambda, and the work functions of three metals are W1, W2 and W3. The variation of stopping potentials V0 with 1 by lambda for the three metals has been shown in the figure, in the graph. Which of the following statements are correct? Here is the graph given. So we can write as W equals to W1 equals to H mu 01 equals to H C upon lambda 01. We know it. So W1 is to W2 is to W3 equals to HC upon lambda 01 is to HC upon lambda 02 is to HC upon lambda 03 equals to 1 by lambda 01 is to 1 by lambda 02 is to 1 by lambda 03. Now here 1 by lambda value for W1 this, for W2 this, for W2 this. So you can write 0.001 is to 0.002 is to 0.004. Multiplying by 1000 we can get 1 is to 2 is to 4. So the answer A is correct one. Now EV0 equals to the stopping where V0 is the topping potential and E0 is the total energy, and that is equals to H nu of minus W0. E0 is the Emax. We know Emax equals to H nu minus W0. So from which this? Now V0 equals to H nu upon E minus W0 upon E. So Hc upon E 1 by lambda minus W0 upon E. So we can say that if we compare this V0 along y-axis and 1 by lambda along x-axis, we can write y equals to mx plus minus c, mx minus c form, where we get m as hc by e, because this is for y and this is for x, and this is for c value, constant value. W0 upon E is constant value, we know. W0 is the work function for metal and E is the electronic charge. So Hc upon E is the, and these three are parallel to each other. So we can write slope of each equals to Hc upon E. So answer A and C. Now 7. When light of wavelength 5000 angstrom is incident on a metal surface, the photoelectric saturation current is 0.40 microampere and stopping potential is 1.36 volt. Choose the correct options. Here is the 4 answers given here. Energy of incident photon is 2.47 eV. Work function, we have to find the energy of the photon as equals to h nu equals to hc upon lambda equals to 6.6 into 10 to the power minus 34 into 3 into 10 to the power this divided 5000 angstrom আছে, there is 10 to the power minus 10 meters. So this is hc upon lambda. This is SI unit. Now this is where we know 1 EV equals to 19 into 1 volt. So this is 1.6 into 10 to the minus 19 joule, because 1 electron 1.6 into 10 to the minus 19 coulomb and V is the 1 volt. So this is in, so we can write at the joule. So at the joule we can write E equals to 6.6 into 3 and 10 to the power minus 26. This divided by 5 into 10 to the power minus 7 into 1.6 into 10 to the power minus 19. So EV. Ten to the power minus 26 minus 26 plus 26 at AV equals to EV. So energy of incident photon is 2.47 EV. Now work function and stopping potential is 1.36. So we know H nu equals to EV0 minus plus W0. So here is 2.47 and EV0, V0 is given as 1.36. So EV0 will be 1.36 EV. This is EV unit. This is EV unit plus W0 implies W0 equals to 4 के साथ 3 के 4 एक 1.8 EV. So this one is the answer. So A and B is the answer. Answer A and B. In the figure, results of a photoelectric experiment has been shown. ABCD are radiations of 4 different wavelengths. Choose the correct alternatives from below. A is ABCD 4 radiations, different radiations, আলাদা আলাদা আলোক রশ্মি, যাদের ডায়াগ্রাম এদিকে আছে ফটোইলেকট্রিক কারেন্ট আর এদিকে আছে পোটেনশিয়াল। সো এদিকে বুঝতেই পারছি এদিকে হচ্ছে স্টপিং পোটেনশিয়াল যাচ্ছে, এদিকে পোটেনশিয়াল যাচ্ছে, এদিকে কি নেগেটিভ দিক কি হবে, নেগেটিভ। হোয়াট ইজ স্টপিং পোটেনশিয়াল? The negative voltage applied to the metal surface for reducing its Emax 0 is called stopping potential. For emerging no photoelectrons or for reducing its Emax 0 is called stopping potential. এটাকে বাংলায় বলে নিবৃত্তি বিভব, যেটা কি যে ওই ইম্যাক্স অর্থাৎ ওর যে এনার্জি, যে কাইনেটিক এনার্জি যেটা সেটা জিরো হয়ে যাবে, ইলেকট্রনের কাইনেটিক এনার্জি জিরো হয়ে যাবে, ইলেকট্রন বেরোচ্ছে কাইনেটিক এনার্জি জিরো, বলছে জিরো হবে, সেই সময় নেগেটিভ ভোল্টেজ দিলে পরে ওটা হয়ে যায়, সেটা নিবৃত্তি বিভব বলছে, ইংলিশ বলছে স্টপিং পোটেনশিয়াল। সো হিয়ার উই obtained by A rays stopping potential is here. For B rays the stopping potential is maximum. So we know EV0 equals to H nu minus W0, where EV0 is the Emax. So we can write that it is a constant. So V0 varies nu. So we can write that B has the largest frequency because here stopping potential is maximum. So B is so answer is right. একই ভাবে C এর জন্য কি হচ্ছে, স্টপিং পোটেনশিয়াল মিনিমাম হচ্ছে। So we can write here for C stopping potential minimum আছে, means frequency minimum আছে। So frequency equals C by lambda, so lambda maximum আছে, C by lambda equals to nu. So nu, when nu means C by lambda max, where C is the velocity of current, C is the velocity of light ray, in vacuum or in air. So C, it is also right. C has the largest wavelength. Number C, A emits maximum number of photoelectrons. A is the rays where this obtained a photoelectric current here maximum. What does it mean? Photoelectric current means the number of photoelectrons is maximum in this case. If the number of photoelectrons is maximum, then the current will be maximum, because what is the current? The flow of photoelectrons in the reverse direction is called photoelectric current. So you can write here, as A emits maximum number of photoelectrons, it is also right. So C is also right. B emits photoelectrons. B emits photoelectrons with the largest momentum. Here we see এখানে আমরা দেখছি যে স্টপিং পটেনশিয়ালটা ম্যাক্সিমাম আছে, দ্যাট ইজ we know from this equation E V0 equals to H nu minus W0. So we can write that E V0 and mu are proportional to each other. তো এখানে দেখতে পাচ্ছি নিউ V0 বাড়ে তো নিউ বাড়ছে মানে H nu বাড়ছে, H is constant, H nu বাড়ছে. What is H nu? Is the energy. It is the total energy by the ray by which this ray is bombarding the metal surface. So we can write that V0 maximum means H nu maximum, H nu energy maximum. So energy maximum means velocity maximum, momentum maximum, kinetic energy maximum. So B emits photoelectrons with largest moment. It is also right. So A, B, C and D, 4 options are right here, correct here. So this is all about our this chapter lecture, dual nature of matter and radiation. My channel's name is Vidyut Flow. You may subscribe it if you like it. Thank you. We will meet you again in next class.